Good morning and welcome back to Youth Codes Jams online Bits and Bytes Club. Today we're going to be switching gears a little bit. We're going to be doing a program in Java, which is a type-based language, as opposed to our Scratch activities, which are block-based. So it will be a little bit more similar to what we did last week with the Kano art stuff, but it won't have any images or graphics associated with it. This is going to be straight code. So it's going to be typing based, text-based typing. So if you're not used to typing, this might be a little bit more challenging for you. I'm not going to discourage you from doing it. It's good practice. It just might take you a little bit more time. That's fine. I stated before, there's lots of free online programs that you can go use to practice your typing. But this is good exposure too. It's a very simple program, so it won't be too much of an overload for you. And if you're used to typing, will also be good practice for you guys. Okay, so as a reminder, we upload our videos on Mondays and Wednesdays. Our Q&A sessions are held on Tuesdays and Thursdays. To register for the Q&A, just go to bit.ly/YCJ virtual lesson QA and make sure you download Zoom beforehand. In today's activity, we have our English and Spanish activity sheets. So you'll type in those URLs into your address bar for whichever one you need. I'll be working from the English version today. The Spanish one, I think you should, so everything's in Spanish, but the text, what you type will be in English. There is not a way to translate into Spanish with the online compiler that we'll be using today. So let's go ahead and jump into the activity by downloading our activity sheets. Exit and pull up my browser. And we're going to I'm going to type in the one for the English version, YCJ Java-E. And I'm going to go ahead and download. Where's my download? So download button's up here. It looks like a half open box with an arrow pointing down. Just hit download. Okay, so mine, when I download from Safari, mine automatically downloads into my download folder and then opens it in Adobe. Yours may not do that. That's okay. Let's minimize some of these things. So if yours didn't do that, if you're on a Mac device, a MacBook, a Mac desktop, whatever, it's going to be in your downloads folder, which is down here in the docking station in the bottom right of your screen. So you can just click that and wherever it is, you can just click it once and open it. So I opened the Spanish version. So yeah, so that's what the Spanish version looks like. I'm going to close out. If you're not on a Mac or you can't find your downloads folder on a Mac, you're going to go to, on Mac, you can also go to Finder. On Windows, it's just that manila file folder. You can click on that one, and in this part of your directory, it will look different, but it's the same kind of setup on both Macs and Windows computers. You're going to look for your downloads folder, and then you'll look for the name of the file. All of our file names start off with VL- and then the name of the activity. So today you'll either look for VL-Java Intro or VL-Java Intro Spanish. So whichever one of those you download, you'll look for that file name in your downloads folder. Okay, so before we code, let's take a look at our activity sheet. So our activity is called Hello World, and if you've done any coding projects, you'll be used to this, or you might start noticing it when you look at coding projects. When you first start out, you will always make a program called Hello World. I don't really know the history behind it. It's just something that's done. So your whole program is to be able to type out a message, and it's Hello World because you're saying hello for the first time with your code. So the Java language has more syntax to it, and what syntax is like punctuation or keywords. So there will be built into Java, there will be certain words like the word new or the word class are keywords that indicate that a certain format and a certain thing should follow it in the language. Whereas when we were using block coding, we just pulled and dragged and dropped a bunch of blocks onto the page. We didn't have syntax. We didn't really have a lot in, we had some in Kano. So with Kano, we had our keywords where we would have circle, and then it would tell us that we had, these are the parameters that follow. And occasionally you had, when you were drawing a polygon, you had commas between the coordinates that you were putting in for where the corners were on our polygon. So that's kind of like that, but there's going to be more to it. Java also uses brackets for curly brackets, square brackets, parentheses. The exclamation point is used as the not operator. So if you remember in Scratch, let's pull it up real quick. So in Scratch, there we go. Maybe. So in Scratch, we had our operators. Ooh, it's running slow today. My computer's very tired. So this was our operators, and here we had the word not. So in Java and other text-based typing languages, you'd actually use an exclamation point and then maybe an equal sign. So not equals, or not greater than, or not less than, or I mix those two up, not greater than, not less than. And then instead of using the words and or, for and you would use a double ampersand. And then for or you would use a double pipe character. You don't need to worry about all that today. I'm just trying to give you some background of what's different between what we've seen in block coding and what we're going to see in text coding. So as we go through this, I will try to explain things to the best of my ability. And so we're going to be double checking this activity sheet a lot. But to go ahead and start, we're going to go to this link right here, https://repl.it languages.java. And what this is this is an online integrated development environment. And what this does is it allows you to create a program that needs to be compiled and or interpreted. And what that means is that it will actually run. So you could have I have this program on my computer called Text Wrangler. This lets me do any kind of document in a text. I can make a Java file, I can make an HTML file, I can make a C file just typing in here. I can't execute anything I type on here. This is just a file. So I don't know if it works or not until I can get to an IDE to let me actually compile and test my program. There are a lot of free ones. This one is really that are online. You can just type in online compiler for whatever language you need. What's good about this one and what's hard to find is that it lets you work with multiple files. So with Java, as it loads, we'll talk about it. Java is, so go ahead and highlight and delete the default text. We'll make our own as we go. So with Java, you see you can add files in a folder. So what it lets you do is you can test larger size programs on here instead of everything has to be in one file, which is really good for languages like Java because as you'll see in step 1 here, Java is an object-oriented programming language. So what that means is that when you write in Java, you want to break as much out as possible so that in the class we're about to run, we would just have main, and main would be what executes the program. But we might have other classes that are built off of it. So one common example is you might have so what did we do? Let me pull up an example from my class. That will be easier than me coming up with something off the top of my head. So for one of my labs, we did lab 2, print array, grade statistics, reverse. I think it was 3. Yep. So we had, and I'm just gonna pull up some code here. Test cylinder. Okay, so what we started with was the circle class. And what this is it holds some values that are associated with the circle. So a circle has a radius which is the length from the edge of the circle to the center of the circle, and then we gave this circle a color, and we use that as a string. So it doesn't actually change the color, we're just saying this circle should be red. So what this does is that it creates the circle as an object. So it's a thing, and it's the idea of the circle, and we gave it some values, some default values that can be overridden in other classes. So that's what's going on here. It's just creating the idea and setting some values to it. And then the cylinder class extends the circle. So we're going to take, so a cylinder, in case you guys don't know, is this. So it's based, it has some characteristics of a circle, but it's more of a 3D element, and a circle is a 2D element or object. So here we added to our circle, we extended it. So by extends, we are inheriting all those, we're going to inherit the radius and the color from the circle class. We also get to inherit these methods, which are actions or functions that the program can do to either come up with a value or store a value or set a value to one of two. So like in our setter values, we have, where is it? Set radius. So this value right here, this method right here, we pass a value and set the radius to it. Up here we have get radius, in which we pass it back to our program. So we can do, so we'll inherit those two. And in cylinder, we add height so that we can get that 3D element, and add some other stuff to adjust the class above to work for a cylinder. But we're not changing the class above because we might want to use circle to in a different program or just by itself. So we extended it for cylinder. So that kind of, it's hard to explain, but that's kind of the idea of object-oriented. You have one object and you can extend it or use it on its own. And then the other part is that you don't run your execution code in your classes. So your classes can be used to just set up the object, and then you'll have a special class where you, which is still, it's all declared the same with a class, but you'll have one class where you actually execute the code. And that's the ideal. It's a little confusing when you first start out. My Java class initially let me do everything in one file, my very first one, and then they tried to switch us to object-oriented programming. It's easier now that I've done so much of it, and I'm used to breaking things out and connecting the files and all that, but it was challenging at first. So originally, when they first did it, everything in these two files would have been in this one for me. But this breaks it all up and makes my files cleaner and easier to edit. And that way, if we need to go back and fix something in one of them, we're just fixing one file. So like if I had messed up my radius here and it was causing problems when I called it to execute here in my test file, then I would only have to go back and fix this one instead of fixing multiple files or digging through 100 lines or more of code to figure out where that error was. So that's kind of the idea with object-oriented programming. And it's associated with languages like Java. I'm going back to our editor now. Okay, I'm going to push it to the side so that we can see the activity sheet. But that idea of breaking up your code and having it in files that are where everything's related to each other, that's pretty broad across programming. We did it with my C class. I've done it with my systems class right now. So even though it's not called object-oriented programming all the time, that idea persists with other languages. Okay, so let's go ahead and start typing. So our first thing we're going to do, if we look at step 1, is we're going to create our class. And we're going to call it main and do 2 curly brackets. So it's important you type it like this. So as I said earlier, class is a keyword. So we need to declare it. It's a keyword, it's a type. So we're telling the program that this is a class and that there's going to be something inside of it. It may execute, it may not. Classes do not always have to execute. This one will, because it's a very simple program. And classes always start with a capital letter. So the name should always start with a capital letter. So let's go into our editor. And on line 1, we're going to type class and then main, open curly bracket. So to get the curly bracket, you're going to hold down your shift key and then the button right next to the P on your keyboard, the curly brackets up top, you're going to hit that once. And you'll see it auto-generated the closing one. That's fine. That works great. We're going to hit enter. All right, so here's part of Java that we need to know with syntax. We put, whenever you have an opening bracket, you need to have a closing bracket, and they need to align. If we started over here, you probably could. It might cause some problems. It makes it easier if you have an indent inside of this so that you know I'm inside of class main right now. So we have the opening and the closing, and then on to step 2 is we're going to create our main method. And this is a method that all programs will have, but they will only have it in one location. So like in the example I showed you from my classwork, that one location was the test cylinder file. And that's where I actually executed all the code I had written and used for that project. So this is a special one. You're going to have all these keywords. So public means it's accessible to everything in the program. Static just means that we're not going to change it. What's in there stays like it. And void means we're not returning anything. So this is our return value. Oh, here's what's static means we can run the method without creating a new instance of the main class. So we can just run it and we don't have to initialize or declare it, which you'll see with bigger projects is that when you have a class, you will initialize it to work with another class. With the main, you don't have to do that. So the void, again, means we're not going to return anything. What happens inside this class is what happens. We don't need to store anything that goes on in there. Okay. And then these are just the string args are standard for all of the main programs. Sometimes you might change them depending on your needs. But this is just default to accept if we are reading something into the file or if we just tell it that we need to accept input when it runs. That's what it's looking for. So we're going to go back to our editor, and on line 2, you're going to type public. Now this is all lowercase, and that's important too. Case matters in Java. It's a case-sensitive language. So public static void main open parentheses, and to get that, you hold down your shift key and then hit your 9 key, and that will give you the open parentheses. And inside there, we're going to type string, square bracket, and args. So string, to get the square brackets, hit the key next to the P, move your cursor outside, and then type args. And then now that this is a function or a method definition. That's the header part of it. And then we're going to build the body inside there. So do the curly bracket at the end. It pushed mine to the end of the line. That's okay. To the start of the next line, that's fine. So open curly bracket, hit enter, and then we'll be ready to go. I thought of something I wanted to tell you. Now I can't remember. It will come back to me. Oh, case sensitive. So what that means is that if I made a variable, that means a couple. So case sensitive means that if I made a variable int a, and I told it that it was going to mean 2, and then I made a variable int a, and I said it meant 0. These are not the same. That's actually a bad example. Let me do, so a string would be one. So if I spelled string, let's do string A is cat, and string B is cat, all uppercase. Even though these are the same words, they are not the same. Java reads them as 2 different things because lowercase letters have different values or counted differently than uppercase values. So if we did a comparison on them, it would come out false. So if I did if A equals B, print true. Now this is not our thing. I'm just showing you examples of how it works. But you're welcome to copy it and practice testing. Print ln false. So what this is it's an if-then statement, which we've seen in Scratch. So this is my if, and this is my conditions. I'm calling an equals method. So this is default with string. So with string, we would do the equals instead of the equals sign. So if I did, I'll show you in a second. So what this does is it compares these two. And if they're considered the same, it will print true. Otherwise, it's going to print false. So let's run it. I got an error. Print ln. Cannot find symbol. Print ln. Why not? Oh, sorry. We need system out. We have to tell it to go out. I'm mixing up my programming language, I think. All right, let's run it again. So it printed out false right there. So it's not the same. Now, if I had tried to run it as A equals B, you'll see when it finishes running, I'm going to get a error. Oh, nope, it printed out false. So what that did here is that it compared A itself to B, which can be done. So that's where we messed up there. So if I wanted to really do this, we could do, let's type it directly. So A is not equal to B because A is worth like, I'm gonna mess it up, I always do. A is like 65 and B is 66 and the values that Java uses. So let's try it like that. So we should be getting an error because it's not supposed to support, you're not supposed to be able to compare strings with the double equals. And the reason it's double equals, this is equals encoding. So you have to use two equals because this is an assignment operator. And what that means is B is, whereas cat equals cat. So I could have x equals, if you've seen it in math, x equals 4. But this is A is cat, or A holds cat, because this is a variable. So B has cat all uppercase, or B stores cat all uppercase. So that's some stuff. I don't know why I couldn't generate the error for you. Different compilers operate a little differently. But let's get back to our main program. So now we're going to use something I just showed you, which is called the print line. So what we have to do is, let's break that down, and I am going to read to you from the activity sheet. So that first command that we use to print is system, and it's a package that contains utility code. Java has a lot of packages and libraries that you can access, and that's part of the object-oriented part of the language, is that you're only pulling in and using what you need, so you don't always have access to everything. So until you want to use the system utility, you're not going to have access to it. So if you try to use it and you haven't imported it into your program, then it's not going to run. You're going to get errors. It will run here because the IDE already has it imported into our statement. So this is a little bit of an exception. Okay, so the system package contains the variable called out, and this allows us to output to our screen. We can also use this to output to a file that has a lot more going on to it, but it's the same. You essentially use the same line with a bunch of other code around it. Okay, so we're going to have, so we'll use out, and then the print ln means we're going to print on a line and then create a new line. So if you could just do print and then anything you ran after it would attach to the end. This one pushes it on to the next line. So let's go type that in there. So 1, 2, 3, 4. So I messed up my indents. That's why I did that. So system out, print ln, open parentheses, double quotes for strings, You can use single quotes, I think, but with Java, it's best to do the double quotes. And then at the very end of this line, see how it's giving me this squiggly red line? A lot of IDEs will do this where they give you hints as you code. You need to add the semicolon. So this tells our program that this is the end of the command, and this is where we stop executing and either go to the next one or stop running the program. Okay, so we're going to press run now. Okay, so you see it says hello world. I don't know why mine has so much words. So that was pretty simple. I can show you let's do a quick loop. So I'm going to create a counter variable. So we saw this in Scratch. So I'm going to set it to 0. I'm going to do while counter is less than, let's do less than 10. We're going to print out and you can copy this again so you get the practice, or you can just watch. So this is going to print hello world out 10 times on different lines. And what's important to add in here is that I increase that counter variable. So I'm going to add counter plus plus. This is going to increase it by 1. I could set my counter to 10 and decrease to 0. In fact, let's do that on the next one. I'm going to do another, we're going to call it counter 2. I'm going to set it to 10. I'm going to do another while loop. So this will execute until we hit this condition. So I want it to stop actually when it's less than, while it's under 10. Yep, that's what I wanted to do. And while counter is greater than 0, so it will stop. So this counter will execute when it hits 10. This one's going to stop when it hits 0. And on this one, we're going to see the regular print, system out print. So you can see what the differences are between them. And then, as usual, decrease counter 2. So the double minus sign, we're going to decrease it by 1. You could add numbers after this, and it would just, I think it would be a little different. No, you can't add numbers after it. It's a different operation. So this one just has it increased by 1. This one has it decreased by 2. And I can also, let's go ahead and print out, we're going to print out the counter value. Print ln. Counter. So if it's a variable, you don't need to put it in the double quotes, only if it's a literal string, an actual string there. And then I want us to do, we're going to do it here too. We're going to do system, and we're going to use the same method. So that will actually be nice and will provide us a little break. Counter 2. And again, so look at my code. We have like declared and initialized a counter variable, so that that's important to do. Java likes you to initialize your variables, which means to give them a value to hold, to put something in that's stored so that you have a starting point. On my while loop, so this is one of the loops, we've seen it in Scratch. I think the best equivalent is the repeat until. Or just the repeat, depending on if you want to put an operator in there. So while the counter is less than 10, we're going to print out the counter value on a new line and then print out hello world. And then we'll increase the counter by 1. And then down here, I declared a new counter variable. I set it to 10. So while the counter is greater than, while counter 2, sorry, that would have caused an error, is greater than 0, we're going to print out the number the counter is on and the string, and then we're going to decrease the counter. Let's go ahead and run this. Okay, so these few lines, the 0 is where we started. That's my starting variable. And that's where we ended. So we got a new, the ln means print on the line and then start a new line. So it printed 0, printed hello world on its new lines, and it continued like that And here's where we stopped. So our last count, when we entered this loop, we went to 9 and printed that out and then hit hello world. And then it increased to 10. It went back into the while loop and it said 10 less than 10 is false. So I'm exiting this loop. So that's when it stopped. If we had left it less than or equal to 10, it would have printed one more time. And then on counter 2, it did this same thing but kind of reversed. So we started with 10 and printed hello world, and then went to 9 and printed hello world. And because we didn't do the ln, it all printed on one line right next to each other. We didn't add any spaces. We didn't tell it to go to a new line. So it's all one line, only a space between the hello and the world. And then you'll see hello world 1. So this last one, it went to 1, looped back up to the top. Well, it started so it printed out 1 here, printed out hello world, decreased by 1 to 0, went back up to the top. So counter 2 was worth 0 here. So 0 is greater than 0 is false, so it exited, and that was the end of our program. Okay, so I know that's a lot. I just kind of wanted to give you an overview of some stuff and give you a little bit more info about how Java works in case you want to keep practicing with it. That's the end of our lesson. I actually think I gave you some hints. So let's look at our adventure mode. Try to print out goodbye. So I think you can figure out that one. You can probably also figure out how to print out some other messages. Print hello world 5 times. Ask the user for their name and print out hello insert username. Okay, so I'm going to, how would we do that? Well, that's your challenge. If you come to the, it's actually really easy. I have code for it. Right here somewhere, maybe? No, we hard set that one. I want you to figure that one out and show me. You can teach me how you do that one if you come to the Q&A session that we'll have on Thursday, April, not the 9th, Thursday, April the 9th. Will be our next meeting, our next Q&A session, and we'll go over this one. I'm happy to show you Java projects that I have that I've been working on. One thing that you can do with Java is use it to build applications, which is a class I'm taking right now. It's called an applications programming class, but we're basing it in Java. So I can show you real quick what my latest project is. So that you can see what you can do, and it will look intimidating right now if you're new, but I promise that you can get to this point. It just takes time and practice. So I'm launching my program. This will be a good test to see if it works. So here I launched a window, and I have 3 buttons. So if I click on need, it takes me to this page, and I hit that button, so it submitted my user ID. If I click item lookup, I have an inventory list that populates this text area box. I can type in, if I type in pizza and the question mark, it looks up a number. If I type in celery, and click lookup, it says if quantity doesn't change after clicking the question mark, the item is not in inventory. If I try to submit that, I get an error message because it's not in the right format. What else could we do? So I could add this. I could change this to add. And so what that did was it added it to the inventory list. So now see, celery's in here, and I can go to celery and look up, and it tells me how much is there. And then I can remove celery if I want. Oh, and I got an error. So what that did was, there's still some bugs. It completed this part of it, but it didn't save my user ID. So we're gonna go back to home, and then on inventory, it shows you what's currently available or in stock. So that's pretty simple. It took a lot of coding hours though, but it's a very simple program, and that's something that you can do with Java as you get more advanced with it and even more powerful things. So yeah, I'm really curious to see how you guys feel about the typing and working with Java, and if you're more interested in doing some of that. I realize this lesson may have been a little bit more advanced for some of you. That's okay. Exposure to this doesn't hurt, and then it's less scary when you see it later. But we do have we have a little bit older kids or kids who have done programming like this, so I wanted to make sure they had a challenging activity or had a way to go play with Java at home. So that they could work with it if they wanted to. And I hope to see you guys next time. Have a great day.